Hi guys, today we are going to look at the product rule. In the exam you're going to get a formula sheet. The formula sheet is specific to the calculus exam, so it's called the mathematics formula sheet. And on there are lots of formulas that will be useful, and we'll have a look at some of those, but I've put it up on the workspace now so that you can see it. One of the things that we are going to learn is the product rule, and it has a formula on the formula sheet, but I prefer to use this one, which is very similar. So what we're saying is if our function is equal to f and a g. Now, from now you don't need to understand what the f and g are, but what they are is two different functions. When we differentiate them, we're going to call that f dashed of x, and it equals f dashed of g plus g dashed of f. Now, on the formula sheet, it says g dashed of f plus f dashed of g. I don't know why. I prefer this one because then it stays the same for the next rule that we're going to use. So f dash g plus g dash f. So that's on the formula sheet. And what f and g are is separate functions of x. So when we're using the product rule, you'll find that whatever equation we're dealing with will normally have at least two x's in it. So if we have a look at one, we've got y equals, remembered it this time, 5x squared plus 2 times 3x cubed. All right. So if I rubbed out everything else on the blackboard, whiteboard, we would have an x times an x. If this was supposed to be a chain rule problem, the likelihood is there'd only be one x. It would be y equals x surrounded by a whole lot of other numbers and applications. But in this case, it's one thing times another thing. So we've got an f function and a g function. This is f, this is g. So to find the differential of this, what we do is we find f dash. So f dashed equals and g dashed equals. So for f dashed, we're going to get 10x, and for g dashed, we're going to get 9x squared. And we put it together again in this order here. So dy by dx will equal f dash, 10x, brackets all the time, every time you put something down. So 10x times g, 3x cubed, plus, that's the one that people miss out, the plus sign. And then g dash, 9x squared, and f 5x squared plus 2. We leave it like that. But for today, what we're going to do is multiply it out just to prove that it does equal the same. So we've got 30x cubed here. We've got 45, that's not a cube, that's a 4, x to the 4 here, and we've got 9 times 2 is 18x squared. So it's 75 x to the 4 plus 18x squared. All right. We would leave it here though if this was in the exam. We wouldn't go around multiplying things out and making mistakes. So does that equal, well, I picked a nice easy one here that we can multiply out. So y equals 15x to the 5 plus 6x to the 3. So when we differentiate that, y dash equals 5 times 15 is 75x to the 4 plus 18x squared. So I wanted to see you to see that this actually does do the same thing as if we multiply it out. So that's a pretty easy one. It's not likely that you're going to get one like that. It's probably not likely you're going to get one like the next one either. But we're going to have a look at one that's a little bit more difficult. So another example. So in this example, we've got y equals 4x plus 3 to the power of 3 and 2x minus 3 to the power of 5. So in that first example, it wouldn't have been wrong, and they will mark you right, if you had multiplied it out and then differentiated it. And it actually would have been quicker. But in this case, if you went around multiplying it out and doing it, they probably won't, you won't pass probably, because this would take you 20 minutes to do. We're not even going to go there to prove it because it will take so long. So what we're saying here is that f is equal to 4x plus 3 cubed, and g equals 2x minus 3 to the power of 5. Remember, it could have negatives and it could have square roots and things. It's still going to be that particular thing. Those two things being multiplied. This times this. So we put them together. When we differentiate them, f dash equals 4x plus 3 squared. And then remember to unwrap the present. This is a chain rule. Here's the function. Another chain rule. Here's the function. All right, so do the outside, 3 of these squared, multiplied by whatever the inside of the bracket differentiates to. And this one, g dash equals 5 2x minus 3 to the power of 4 times 2. Now those aren't too particularly difficult to multiply out, so you could multiply those out, but I'm not going to, because what we say is don't do it. So we'll just leave it as it is and put it together now. So f dash g plus g dash f. F dash is 4x plus 3 squared times 4 times g. G is 2x minus 3 to the power of 5 plus g dash 5 times 2x minus 3 to the power of 4 times 2 times f 4x plus 3 to the power of 3. Finished. Leave it here. Now the likelihood is that if you were having a polynomial one like this, you'd have to actually substitute in and find the gradient or something like that. And that's not actually that difficult to substitute into. You could go through in your calculator and easily put that in with a number in for x everywhere. So we'll leave it like that. We're not going to change it, and away we go. All right. So I've set a little exercise out of Delta Book today for you, and hopefully that won't take you very long. Thanks, guys. See you later.